and then let's go ahead and get started. So I'm Kelly Lockhart. I'm a developer here with ADS. My background is in astronomy, so I can sort of answer some of your questions from the astronomy side, but also if you have more technical questions, I've done a lot of development on some of the back-end stuff within ADS. So I can answer your questions from either direction. And feel free, this is supposed to be more of a discussion. So if you have any questions, particularly as we get to the example section towards the end, feel free to ask questions as we go. Let's see if I can make this go. There we go. Okay, so your first question maybe.
New to transition.
Oh, right. Good call. Okay, so your first question, if you are new to this whole thing, is what is an API? So to answer that, let me give you an overview of just what our infrastructure looks like in ADS in general. So when you first go to the ADS website, when you enter in any sort of searches or if you try to do any actions on the website will translate what you're asking it to do into a series of requests. You don't really need to know exactly what those are. They're just individual packets of information or requests for information. And all of those get passed into our API gateway. You can think of the API gateway as sort of a switchboard operator. So a switchboard operator answers incoming calls and directs them to the person where they're supposed to go. So same thing with the API gateway. It answers incoming requests. It looks at the request to see who it's supposed to go to. In this case, instead of a person, it's going to go to a microservice. And then it's going to send it off to the appropriate microservice. So a microservice is just a small individualized piece of code that deals with one very specific function. So we have a bunch of different microservices. We have one that deals with our search engine. That one will send out requests to our database to go look at the information that you're asking it for. We have one, for example, for our library system. So if you have an ADS library, we have a database that stores all your library information and stores all of your libraries that you've put together. We also have one for our export service. So our export service will translate any of your abstracts that you're interested in into BibTeX or any other format that you need. So microservices, they store information, they perform actions, but they're usually fairly atomic. They deal with just one small piece of ADS. So the API gateway will figure out where your request should go, send it out to the appropriate microservice. The microservice will either get your information for you or it'll perform the action that you asked of it. And then once it has done all of that, it sends its response back to the API gateway. API gateway gathers that all back up and sends it back out to whoever made the request. So in this case, it would send it back out to the ADS website. So that's probably what most of y'all deal with day to day. The cool thing, though, with the way we've done our infrastructure now is you don't actually have to use the website to do everything else. So the website makes it really convenient. It's a pretty interface. You can type things really nicely. You can click on things. But none of that is actually necessary for doing the vast majority of things within ADS. So if you want to do a search, if you want to interact with your libraries, if you want to do an export, or any of the other functions in ADS, the vast majority of those can be done actually using the command line interface. And that's what we're talking about today, is how to interact with the API, not using the website, but instead using the command line. So you might wonder, why exactly would I use the API? The website's really convenient. You can bookmark it in your web browser. Clicking around is really nice and convenient. But there's a few things that make the API make a lot easier than the website. So for example, if you need to rerun the same query periodically, maybe you have a particular object that you're working on a paper for, and you want to make sure you're always getting the latest papers, the latest literature about that object you're working on. So maybe once a month you want to go to ADS and do a query for that exact same object every single month. You could do that by hand. You could have a calendar reminder and just go and do that. It might, however, be easier just to script that. So you have maybe a cron job or something else that will go and fetch that those latest papers for you once a month or something like that. That's all easily done with the scripts and with the API. You might also be needing to run the exact same query for multiple people or multiple bib codes. So maybe you want to go get your citation metrics for every single one of your papers, and you want to do it individually instead of just all of your papers at once. So in that case, you would probably be feeding individual bib codes into the website, just one at a time. If you have more than a handful of papers, you could see that would be a lot of work, just copying and pasting every bib code and getting the information back out. So instead, what would probably be easier is if you use like Python or something, have a for loop to go through a list of your bib codes. Easy enough, you get all your information out without having to do a ton of work. Another thing is if you want to use the search results in some sort of scripted analysis. So say you're not just wanting to look at the papers, list of papers that match a search, and kind of browse through them and read papers, but maybe you're trying to do some sort of analysis, some sort of citation analysis, anything else that you might think of. We have some examples actually on our blog of different sorts of analyses you might want to do. But all of that, if you are going to continue to do analysis after you've gotten your search results, might be easier to do with, say, a Python script to start with. Instead of having to copy and paste all the information out of the website, if you want to put all that information into another Python script, just start with Python in the first place or whatever in order to get all those results. So the first step of using the API is getting an API token. We make this really easy for you. You just need to have a user account. So if you don't have a user account, go sign up for one. And then once you do, if you go to the customized settings there in the upper right-hand corner, and then from there go to API token on the left-hand side, you'll be brought to this screen. Everybody has one. You don't have to do anything special as long as you have an account. And then where I have that little bar, you'll actually see what your API token is. It's a 30-something digit number and letter string. And then you can just copy and paste that. That's your token. You can use that in your scripts. And you'll see in a second just how you use that. If something ever happens to your API token, if you accidentally put it on GitHub or share it more widely, just click generate a new key. We'll kill your old API token and give you a brand new one that you can use. So why do you need an API token? So basically, we use those to limit the number of requests that people can make. And we have fairly high limits. You can make up to 5,000 queries every day with a single API token without doing anything special. So that's a pretty high limit. Most people aren't going to get anywhere close to that. However, of course, we need to prevent bad actors from getting in and scraping all of the data, doing any other sort of things that you might think people who have bad agendas would do. So that's really just a way of protecting ourselves. It's also a way of protecting y'all. If somebody's going in and making a ton of requests and we can't stop them, then that could be a denial of service attack. You've probably heard of those. Basically, somebody making so many requests that the website just crashes and then ADS is unavailable for anybody else. So it's just a way of protecting us and protecting you and making sure ADS is available. However, there are some valid cases in which you may need more to make more than 5,000 queries a day. In that case, just email us and we can help you figure out what to do. We can up your limits for the day or for a longer period of time. But we're totally willing to work with you and figure out how to help you accomplish your ends. Yeah.
Some idea what a BigQuery means?
Yes, we'll get to that in a second. Yep. But that's a good point. The BigQueries are slightly different. We'll talk a little bit more about like why they're different. Basically, BigQueries though just allow you to request more information at once. So that's why we limit it a little bit more. So there are several different ways to use our API. Like I said, it's all done via the command line, but of course there's several different ways you can use a command line. So the thing that most people think of first is just the regular bash shell, terminal, whatever you call it. So you can use that, and you would make curl requests if you are using bash. Most people don't use bash or terminal for a ton, though. Most people use something more like Python. So you can actually access the API using Python as well. So the first way to use Python with the API is to use the request library. So the request library is just an open source library. It's not an ADS specific thing. A lot of people use the request library to access web services in various forms. So it's the most basic way of using Python. The other way, though, is Andy Casey has written an unofficial ADS library, Python library. You can install that using pip, like you would install any other package, and then you can access our API using that. So there's pluses and minuses to each of these methods. For curl, that's kind of the quick and dirty way to construct queries and to access the API. It makes it really easy to just copy and paste commands directly from the web browser, for example, into curl. Pretty simple to get it up and running. However, if you're not super fluent in using bash scripts, then maybe that's not going to be the best option for you. Python, the request package, makes it easy to create scripts. So if you're going to use the information you get out of ADS later in some sort of script, Python is obviously really easy to use for that. You also still get some of the same easy translation from the web browser to the API queries that you do with curl. So that's sort of a nice way of getting started with that. And finally, the ADS Python library, you can create much more advanced scripts. And they do some sort of fancy things about managing memory. So if you are making a request that gives you back a ton of results, the ADS library does a lot of like fancy stuff to make sure like you're not taking up a ton of memory in your machine. You can see, though, just from the simple example I gave, the way that the query looks is a little different. So instead of having this like URL looking thing that you're putting in, you're actually typing in stuff very similar to what you would type into the web browser. So in some cases that's nice, you don't have to do any sort of translation. In other cases it could make it a little more difficult to do exactly what you're trying to do. So it just has a bit more of a learning curve to it, but you can do some really fancy things with it. So for the purposes of the rest of this talk, I'm actually going to focus just on Python using the request library because I think that's the most common way people access the API. If you have any questions about the other ones, then we can talk about that as well. Okay, and before we get into examples, I want to just talk a little bit about the basics of making an API call. So up the top, I just have a very simple Python request, but with stuff sort of not filled in yet. So the way you make the request, you have the request, and that's just the package that the library that you're referring to, and then .method. So that .method is an HTTP method. We don't really need to get into the specifics of what exactly an HTTP method is. Just know that every single request that you make to the API has a specific method associated with it. Those methods are get, post, put are the ones you're probably going to see. You don't really need to know what those are. Just when you're going and looking at our documentation, you'll see that every different example has one of those three methods associated with it. So just know that you need to pull that out and look specifically at what it's asking you to do. So whatever those methods are would go right there after request dot. You also, like we already talked about, you need your API token, which you just get from the website using your user account. And you put that in at the very end there where it says token. And then finally, you need a URL. So the URL, you just sort of mix and match the pieces. The first part is the base URL, which is that HTTPS all the way through the v1, so that first section of the URL, and you'll use that for every single API query that you make. The next thing, endpoint. So the endpoint is just specific to the type of search. So if you're doing a search, then you would put search there. If you're making a call to a library, you would put libraries there. Again, you don't need to have all this memorized. It's in our documentation, and I'll show you where to get to that documentation after this. So after you have the endpoint, then you might have a query, or you might have something else that's specific to the type of search that you're making. So if you are querying for like an author search or something like that, that's where all of those parameters go, at the very end of the URL. And then finally, one thing I should note is if your HTTP method for whatever query you're trying to make is a post method, you'll also have to do input something that's called a payload or a data parameter. You'll see that in some of the examples. And that just means that the post method is a little bit more complicated. You're making more advanced queries using a post method. And that's where you just put in all the extra information that query needs. Nothing scary. It's just going to be a Python dictionary. And again, there's examples of all of that in our documentation. Just know if you're making a post request, you're going to need to put in a payload with that. Oh, one more thing. So just some general tips before we get into examples. So like I sort of mentioned, the query parameters that you're using, so if you're doing just a general search, the query parameters that you're going to put into the URL are the exact same query parameters that you would have, that you would see in the web browser. So if you make a query in the web browser and you look at that URL, you'll see your query parameters that you've entered, whether it's an author search or your search, are actually encoded in the URL. So what's really nice is you can actually copy and paste that section of the URL and then use it in your API queries. So that makes it really easy to construct API queries when you're first getting started. If you don't really know how to make the URL, just go put it into the web browser and then copy and paste as necessary. You can hack something together. I will note, though, you probably have noticed this when you're just browsing around the web. There are certain characters that you never see in URLs, like you never see spaces, for example. But if you need to have a space, so say if you're entering in an author name or something, you probably have a space involved. So in that case, you just have to do what we call encoding the space. So instead of typing a space, you would type in that %20 character. And you can just do that all by hand. There's lookups on the internet. So if you're trying to find a specific character and you're like, this is breaking my URL, I don't know why, you can go look online, find a URL encoding library, and just copy and paste. Or also Python has some URL encode packages as well. So you could just put in your query string and then run URL encode on those, and it will spit back out all your same query string, just with all those special characters replaced with whatever you need to make it into your URL. I don't know if I really want to talk about any of this because we'll start getting into it. Yeah, I think that's good for right now. Okay, so any questions before I move on into examples? Okay. so if y'all haven't seen this, we have all this documentation that I'm referring to is here in a GitHub repository. Got it? Awesome. Okay. So to get to all of this, this GitHub repository, if, say, you are on ADS, go to About, and then go to the Help pages. And then over here, you'll see using the ADS API. Make that a little bigger. If you click on that, it will have a link out to this GitHub repository. And then all of the information that we're talking about today, plus a ton of examples, are here in a bunch of Jupyter notebooks. So Jupyter notebooks, if y'all aren't familiar, it's a bunch of code examples. You can actually download the Jupyter notebook and just run it yourself. Or you can copy and paste all of the different bits of code that you need as necessary into your own scripts. So we have down here this README. This is a lot of the stuff that we just talked about. But then there's different Jupyter notebooks for every different type of search that you might be doing. So searches or libraries or metrics, all of those things, that's just all nicely divided out. So let's go ahead and look at, okay, so what most of y'all are probably going to be doing is you're probably going to be doing just straight up searches. So the same kind of searches that you're doing within ADS, within the website, you'll also be doing within your Python scripts. So let's just look and see what one of those looks like. So I have this Python window open here. I'm going to make this bigger. Can y'all see that? Not really? Make that a lot bigger. Feel free to move closer if you need to. I don't know how to make that font size much bigger. So if we're going to just be doing a basic search, let me go ahead and copy and paste one of these out of here. So I'm just going to be doing a basic GET request. Let me copy and paste this and I'll tell you what I'm doing. Okay, so like I was saying before, you have the requests, and then this .get is the method that you're using. Get is what most of your just general search results are going to be. That's sort of the default, most basic option. And then at the very end, this headers, bearer, etc. thing, which I think was run off the screen a little bit, has my token. And I've already entered my token. I'm not going to show it to y'all because this is being recorded for posterity, and I don't want to have to go and get a new API token when we're all done with this. So, but I have entered my token as a variable just in Python. And then here is the URL that we were talking about. So we have this base URL, HTTPS, all the way through this v1. And then I'm making a search request. Sergi is showing me that I am running off the screen. Let's make this a little bit better. Okay, cool. So then this base URL, and then I'm making a search. So I have this /search. And then this next part is my actual query. So query $Q equals author, and then I'm searching for the author Martinez. And I'm also looking for neutron and star. So I don't know if y'all can see, but author %3a, that's just that colon URL encoding that we talked about. Martinez has an accent, so it's also got some encoding there in the middle of it. And then neutron and star, I replaced the spaces with plus signs, which will also work. The next part is this and FL equals author. So FL is just what fields you're telling it to return. So if I'm doing a search for Martinez neutron stars, we have a ton of information in our database. So we can find our authors, we can find titles, we can find abstracts, we can find publishers, we can find years, we can find all of this information. So basically you have to tell the API what information exactly you want it to return. It's not going to return everything to you by default, because that would be way too much information for most people. Most people just want code codes, titles, authors, something like that. So this, by saying and FL equals author, I'm saying all I really care about is just giving me the author back. I don't care about anything else. This next thing is and rows equals 1. So by default, it's only going to, the API is only going to give you 10 search results at a time. You can paginate through the results, but by default, it's just going to give you the 10 to start with. That's adjustable. So you can make this, and I forget what the maximum number is, 200 maybe? It's in our documentation. But right now I'm just saying I only want it to give me one result back, one row back. So let's see what this does. Okay, so it doesn't do anything by default. It just goes and processes and then it returns. So if I want to see if it actually worked, I can do r.status code. And I'm doing r because that's what variable I had assigned to the request in the first place. And it returns a 200. So for those of y'all who haven't used APIs much before, 200 just means everything was good, everything was successful. If you get something that starts with a 4, that starts with a 5, something went wrong. So if it starts with a 2, you're good. That's basically all you need to know about status codes. But it's a nice thing if you're doing, if you're writing a script, then you can actually go and make sure that you got results. Check your status code before you continue to process them, or else your script is going to break. If I want to actually go see what my results are, though, the easiest thing is to do r.json, and then it's a method, so I put the parentheses at the end. What JSON is, if y'all haven't seen this before, is it's basically a nice way of structuring the data. So I could also do r.text, and that would just return all of the results back in one big text blob, but that's really hard to process if you're going to be doing script after. So you might have heard of XML maybe. So XML is sort of like the predecessor to JSON. It's just a structured format that you can go through and pull out what exactly you need later. In Python, JSON is basically a dictionary, which is really easy to use if you've done a lot of Python scripting. So if I do that, this is just going to print out my results in a JSON format. And you can see we've got two different parts of the response. We have this response part, and we have the response header part. So the response header is just some of the information. It tells you what exactly you were querying for, so it writes out what your query was. It writes out what that FL parameter you gave it was. So a lot of the stuff that you told it, it will just tell you back, so you know. This response, though, is what you probably actually care about. Within response, you have docs. And within the docs, you have this list. And basically, it's going to list out all of your search results. So everything that you ask it for are going to show up in this response docs. Easy enough. You'll also see we have this num found parameter. So basically, it's saying you only asked me for a single result, and I just gave you the top results. But in actuality, if you had asked for all of them, you would have gotten 181 results. So if you're doing some sort of pagination, so maybe you're asking for 10 results at a time, if you want to know how many results you need to get back altogether, this num found is going to tell you how many results you have altogether. You can just paginate through until you get to the end.
How does it choose which results to give you?
It's based on your sort. So I did not specify any sort method. So basically, it's sorting by this sort of generic document ID number, which you have no idea what your document ID number is. That's an internal to our search engine number. Nowhere within the website does it tell you what the document ID is. So to you, it will just look like a completely random sort. So that's a good question, though, and I'll show you in a second how you can specify what you want your sort order to be. Yes?
So that was an author and neutron and star?
Yes.
All three things?
Yes.
On every single one of those returns?
Yes. Exactly. If you do want to paginate, this start parameter is pretty useful. So start is, the way you paginate is you say, give me 10 results, and I want to start at number X. So in this case, since I didn't tell it to start anywhere in particular, it just started at the top, and it's working its way down. So if you are paginating, say you want to do 10 results at a time and just paginate through all 180 results, you would just iterate what your start parameter is. So start is 0 to start with. The next time around, you would want it to be 10, and then it would return 10 through 19, and onwards. Yes?
So if you're doing pagination and you specifically sorted your list, is there a chance that as you're going through the pagination, it'll come out with a different sort order?
I don't think so, because it is sorted by document ID. Yeah, it depends. There can be some ambiguity if you are sorting by maybe something like date published, because if you have, most of our date published are just a specific month. We have, for the most part, gotten rid of most of those ambiguities, so that shouldn't be a problem anymore. But in early days of the API, sometimes you would see some weird behavior like that. Okay, so that's just a very simple search. I did keep mentioning that you can use the web interface to copy and paste parameters. So let's go see what that looks like. So here I've cheated a little bit and started doing this. So basically I'm searching for, make this bigger. So I'm searching for Alberto's name and for year 2017. So I'm looking for ADS papers. You can see we've got 5 results here that involve Alberto and are all about ADS. So up here in this URL, if y'all can see this, we have our regular base URL for the web, not for the API, so it's ui.ads, abs, whatever. After that, you can see this --search or /search, just like you would do in your API URLs. And then after that, you have the Q equals parameters, and you can see author, Akamatsu, year, 2017, all the same stuff that I've entered here in the web browser is now up here in the URL. Having all of this stuff in the URL means that you can bookmark this URL, and you're always going to get the same search back. That's how we know what information that you want to bookmark is. It's all encoded up here. After that, you can see, Christine, like you asked, the sort. So we automatically, when you're doing the search within the browser, we automatically sort by date, sometimes by score, depending on exactly what kind of search you're doing, but we have a default sort that we do. So this is a good point. Let's go ahead and copy and paste all of this stuff. So I'm copying my search parameters. I'm also copying the sort method. So let's do that. And then come back over here. I'm going to go back over to my Python request, and all I'm going to do is delete this, the end of the previous query. And I'm just going to paste in all of that stuff from the web browser. You'll notice I was a little subtle about it, but I also deleted those FL equals parameters. So if I run this right now, actually, let me just show you what this looks like. So like I said, you get these weird IDs that mean absolutely nothing to you. So if you ever see those, just know that you need to go and enter your FL equals. So I want to do that right now. And each of these separate things that you're putting in, each of these separate parameters, so Q equals, FL equals, rows equals, each of those is separated from the previous one by an ampersand. So I'll do ampersand, oh, I already did that, FL equals, and I'm just going to do author, bib code, title. And I'm going to leave rows at the default, which is 10. I know from the web browser that the number of results I get is 5, so 10 is more than enough. I do that, and then I go with my results. And you can see I have this nice dictionary that has all of my different results. So I've got this set of authors, a bib code, a title, and then for the next result, the authors, the bib code, the title, all the way through. My num found is 5, which is great because my num found here is 5. So you can see that we're accessing the exact same information whether you're going from the web browser or whether you're going from the API. I'm not going to do it right now, but if I actually went through and compared side by side, you can see these are in the same order because I just copy and pasted the sort order from the browser. So all of this information should be exactly the same, and then you can access the information however you need to, and then use it in whatever scripts or anything that you need from there. Okay, so it's 1:30, and I've showed you a couple examples that I think will get most of y'all started. But I wanted to open up. Do y'all have any questions, or do you have any examples that you want me to show you? Okay. So I will go ahead and leave this up here with our API documentation. Again, each of these search notebooks covers a different type of search that you would do. So the one that we were working on was the search API. The examples in this search API Jupyter notebook are actually for bash scripts, just because that's sort of the easiest one to put together. But you might also want to look at this converting Perl to Python. And there's a lot of Python examples in that notebook. And that covers all of the different types of searches you might do. Export libraries, metrics, and search are all in this one with all the proper Python syntax. So again, feel free to download these. Feel free to copy and paste from here. And if you have any questions, feel free to stick around after or email us. We're more than happy to help. Thank you. Yeah.
Would you like to say another reason why people should guard against disclosing their token? For instance, the fact that that gives access to the user's personal information in libraries.
That's a good point. Yeah. So one example I did not show is, but actually, let me go ahead and do that. So I have, within my user account, I have this private library. It's sort of a throwaway library that I've made. And I have set this library is private. It's not a public library, so I'm supposed to be the only one who can access it. I can go and look at this this library using the API by using this the library ID, which shows up in the URL when you're looking at the library. So if I just copy that, and actually I think I did this earlier. Don't mind this. Okay, yeah. So I did do this earlier, where where I was going to go look at this library, and I've just used the endpoint that's appropriate for looking at the library, biblib/libraries. All of this in the documentation, you don't have to remember it. And then I copied and pasted the library ID here at the end of the URL. You can see it's the exact same library ID that I was just looking at. It's a private library. Nobody else is supposed to be able to look at it but me. If I do this, and then go look at the results, it gives me all the information back about the library. It tells me the bib codes that I have in it. I think it has the date that I last modified it. Says the description, the title, all of that information. So if for some reason you have some private libraries that you want to keep private, sharing your API token would allow other people to see those libraries. It's basically as if they were you when they're interfacing with ADS. It's just like sharing your username and password with somebody. So protect your API token because, yeah, otherwise people can imitate you. Good point. Yeah.
This is more related to one of the functions that are now more readily accessible is the number of reads. And some of us pay attention to that for a large number of papers. But now that you've got this API, and I expect you're thinking and probably will have a lot more users coming into the API, how does that affect read results?
Oh, that's a good question. Alberto, do you actually know the answer to that?
So, sorry, the question was how.
Yes. I mean, you and I have had these conversations already, but there's a broader audience. How might the API and a lot of users coming in, getting essentially accessing or reading an API, a bib code, how might that affect reads on a bib code?
Right. So at the moment, it does not, because what we are recording, without giving away the store here, we attempt to record user clicks, so things that happen through the browser. And so the experience in our website, the application that implements the interaction through the website, goes through a particular endpoint that logs the user clicks and distinguishes that from the click that a robot or crawler would make. In addition, we also record essentially something equivalent to an anonymous user ID, which is tied to a browser session. So there's not the possibility of having a simple API request such as this one be confused with that one. Having said that, obviously anybody who really wanted could try to reverse engineer all of this, but that's not what we're trying to aim. So we do other things to make sure we remove crawlers and applications when we make this kind of generate these metrics. Basically.
There is a distinction between the reads count that you get to search and the reads count that you get to metrics. Through search, you get like a 90-day window.
Okay,
So
so
those
search is
come
a
down.
Well, then
let's say some publishing house wants to use it and implement your API into their system to kind of keep track of their articles and stuff like that. And let's say like 100 people who work for the publishing house will use a single API key, so that it will just appear as a single user, right? Basically. So it's not like their ID or something like that. It's like 1,000 people can use the same key. Correct?
Yeah, except we do limit, like I said, there's like 5,000
Right,
requests a day. So we try to encourage people to, as best they can, to just have one person per API token. You know, it's good for both us and for them. So that way you're not stepping on each other's toes. Yeah.
Is anyone using it in publishing your APIs over there? Yeah, I know because some publishers started using this. They blew over our limits right away. But there are librarians and archivists. I mean,
Chaser uses it.
Chaser uses it. So there's scientists who use it for their own searches, as well as people work for libraries or archives and publishers to kind of connect their records with our own or get citations, for instance, citation counts for particular records.
Any other questions? Yeah.
So you said we have a limit of 5,000.
Oh, and I didn't actually talk about BigQueries, or BigQueries. Yes, good point. Okay, so I'm going to just go look at show you all the documentation for BigQueries, because I think that's a little easier to explain. I have too many things open. So what BigQueries are is basically, instead of passing in a search string, for example, so instead of looking for Alberto or looking for neutron stars, I already know the bib codes that I want to go look up, and then I want to get the information for those bib codes, whatever that information is. You can get all the same information, but you already know what those bib codes are, what those papers are. So that's what BigQueries are. And here is an example in our search documentation. So you can see it's actually a slightly different type of query you'll do. Let me actually see, since I was showing you Python, let me see if I can show you Python still. Yeah, okay, so here we go. So this is the exact same type of Python request I was making before. So you can see the headers are a little different. You're not just passing the token, you also have to pass what the content type is, and it's a BigQuery content type, which is where it gets its name. You can see the method is a little different. The method is a post request, not a get request like we were just doing. And so, since it's a post request, you need a payload or a data parameter, which you can see I have here, this data equals bibcodes thing. And then I'm constructing that payload, that data payload up here, so this bibcode thing. And this is just a list of all of the different bibcodes that I want to get information for. So it's a little bit more advanced of a query, but it lets you get exactly the information you want without having to do some other searches. So it's usually used for a very specific type of search that people are doing. It does let you get a lot of information at once. You can do, 2,000 bibcodes at a time? So it's a really, like its name says, it's a big query. So that's why we limit it down to only 100 a day, because you're just getting way more information at once than you would with any other type of query. Good question. Any other questions? Okay, well, we'll be here for another 45 minutes, an hour after, so if you have any more questions, feel free to stick around, and then we'll chat then. Thanks.